right. Good morning. This is Christy Callback-Rose. I'm joining from Martinez, California today. Thank you for joining from wherever you happen to be coming from and whatever time of day it might be there. This is a continuation of our spectrum scale expert talks that we've been doing this year during the shelter in place. This particular talk is part of Supercomputing 2020, overall episode 11, where we'll be covering what's new in spectrum scale 5.1. You can see additional information about the previous expert talks on the URL on the left there. And if you're not already part of our user group, please join with the URL on the right. You'll also find information about joining our Slack channel and just any of the events that we've pre-recorded, or sorry, that we have recorded in the past. Okay, just a few mentions about our user group. This is an independent user group that we do work very closely with IBM to provide. Sorry to say, none of the discussions that you have here today, although you're welcome to ask any questions, are not a replacement for a PMR. So PMRs still need to happen. We do have an email and a Slack community, as well as recordings of the talks and also the slide decks from previous events at the URL there below. So please use that. Please utilize the Slack channel for questions. It's fairly active and people do sort of help each other out on that forum. Okay. So I'm Christy Callback-Rose, like I said, joining from California this morning. We have several upper representatives from around the globe that provide these user groups for you in different locations. We're always looking for more participation in providing these user group events. So if you have any interest in that, please feel free to contact any of us about that. Okay, so here's just a quick rundown of some of the expert talks that have been provided during shelter in place. You'll see quite a list there going all the way back to what's new in Spectrum Scale 505. Today we'll be covering what's new in Spectrum Scale 5.1. But you'll see quite an assortment there of topics that have been covered. And then coming up December 4th, we'll have some event-driven data management discussion and security around the watch folder and file audit logging. So look for more information about that event. Again, on our webpage, you'll find information about joining that session. Okay. So this morning, it's my pleasure to introduce both Chris Maestas from IBM and Ismail Solis from IBM. Chris is the executive architect joining us from New Mexico this morning, and Ismail is a spectrum scale performance analyst joining us from Mexico this morning. So with that, let me pass it over to them, and thanks again for joining us this morning.
Hello, everyone. My name is Ismail Solis. I am a data scientist and performance analyst for the IBM Spectrum Scale. And today I feel very excited because along with my colleague Christopher Maestas, I have this great opportunity to talk about the most important set of additions and enhancements that are introduced in Spectrum Scale 5.1.0. So before entering the actual content, as is normal in this type of presentations, we have our standard disclaimer for legal issues. Okay, let's start. I'm on a wide set of new features and enhancements today. We will be talking about some important changes in the Spectrum Scale, including, number one, the ability to configure QoS at fileset level. This will help you to provide a fine-grained configuration of your system. This also will very help you for achieving the expected operations and bandwidth while you are running your IO-intensive maintenance commands. Number two, the data acceleration for artificial intelligence and analytics using high-performance tier. How IBM Spectrum Scale 5.1.0 can help you to deal with these particular and critical workloads and connect to cloud storage environments. Number three, the enhanced container support for high performance. How Spectrum Scale has evolved since the last versions to provide enhanced usability and performance in containerized environments. Number four, simplify the audit logging and watch folder support technologies using QRadar and Splunk, for example. Always, it is good to know what is happening in our system. With the Spectrum Scale 5.1.0, IBM is providing enhanced mechanisms to deal with unauthorized access, even at a file level. And number five, we will introduce support for latest technologies, including operating systems, Python 3, and of course, integration with IPv6, NFS 4.1, and for sure, this all will bring a stronger potential from different angles to your systems. Along the presentation, we will also talk about other updates that will bring you significant enhancements to your day-to-day operation, including platform support, installation toolkit, core features, ECE, GUI, maps, protocols, AFM, and security. And as usual, we are also listing the discontinued and deprecated features. With all of this, what we are expecting is to provide you an overview of the new capabilities of a Spectrum Scale and giving you a sense about the direction of Spectrum Scale is taking. Let's start with platform updates. In terms of platform updates, what IBM Spectrum Scale is looking for is to support the latest operating system versions as soon as possible and providing support for technologies that enable the next generation of DevOps, security, and enhanced networking. Spectrum Scale 5.1 supports Red Hat Enterprise Linux 7.7, 7.9, A1, A2 for the three principal platforms, x86, PowerPC, and 390X. SUSE Enterprise Linux Server 15 for x86 and 390X. Ubuntu 20.04 for x86 and PowerPC, AX 7.2, and Windows 10 Server 2016 and 2019. Additionally, C Enterprise Data Compression is support for this version on IBM Z15. This might help you to reduce CPU cost and elapsed time for data compression compared to other traditional software-based compression services. Other important enhancements to the overall platform include that 5.1 has been converted fully to Python 3. This involves significant coding efficiencies and enablement of the last generation APIs for high-performance computing. The minimum version that we are supporting for 5.1 is Python 3.6. Scale 5.1 is also providing IPv6 support for protocol nodes. This will allow you the possibility to bring your system network to the next generation technology, which is more flexible, secure, and provide you a wider possibilities for performance improvements. In terms of installation, what the Spectrum Scale 5.1 is looking for is a wider support for installation toolkit, making the installation process easier and transparent across different platforms and versions. In 5.1, the installation toolkit supports Ubuntu 20.04 on x86, Red Hat 7.9 on x86, PowerPC, and 390X. Additionally, for Toolkit 5.1, we are providing support for installing Audit Logging, NFS, SMB, protocols, and SES over x86, 390X, SUSE Linux Enterprise Server 15. So not only installing a Spectrum Scale core is getting simpler, but also installing all the required mechanisms, tools to build complex environments is getting simpler and also possible to do it over different platforms. So let's start with the core improvements. For the case of core improvements in terms of administration and reliability, Spectrum Scale 5.1 is introducing a set of enhancements and additions that are looking for reducing the complexity of the system administration and provide a stronger reliability at all levels. For example, now the license command supports integration with the IBM licensing metric tool. That means that now you will be able to automatically collect, format, and manage all your software licensing requirements. So just for internal licensing review in a very simple way. Other important enhancement that demonstrate the easier management is that now it is possible to change the daemon IP for a quorum node in a CCR-enabled cluster. In the past, the quorum node to a non-quorum node, then change the daemon interface of that quorum node, and finally, you have to change that quorum node back to a quorum node. So now it's much more simpler with a single change node command. In terms of reliability, now we can avoid long waiting RDMA threads hanging in our system. So due to the use of the system sometimes, due to applications or external problems, long waiting RDMA requests start aggregating in our systems. So this reduces the readiness and the performance of our cluster components. So now, with this parameter or attribute verbs hang RDMA timeout, It makes possible to set a cancellation timeout for all these hanging requests, recovering the state of our cluster in a very simple way. Also, sometimes we as administrators do not remember the role of a particular node in our cluster. Okay, so this is particularly hard to do in very large clusters. So first, before shutting down nodes, we can accidentally shut down, for example, quorum nodes. So when the node quorum is lost, all the nodes lost the membership and access to the file system until the quorum is restored. So now with 510, we are warning you when we are shutting down quorum nodes. This will help you to avoid this situation that can potentially and drastically affect the reliability of your system. Core enhancements in relation to Quota. So core enhancements in 510 related to Quota are looking for allowing the possibility of more flexible system administration and simpler utilization. For example, now it is possible to check and recover the quota usage in a more flexible way at a file size level. So using the check quota device, and now we are adding the file set level. Okay. So previously, this was just possible at a device level. So now you have a fine-grained visibility and administration of your resources. Also, checking the output of a quota command or a df command, you can confuse about the replication factor is being accounted in both cases. So in the past, we had to manually estimate the data size. Now, you can ignore the data replication factor for df and quota commands by configuring a couple of attributes: ignore replication on staff and ignore replication quota. So it's on you. Okay, you decide whether to include the replication factor in the data estimation or not. The core enhancements in 510 are focused on improving the performance. That means better mechanisms to recover your data in a faster and reliable way. So for example, in Spectrum Scale 510, we're introducing 3 tuning parameters to enhance the parallelism of log recovery process. These parameters are log recovery threads per log, that you can use to tune the number of active threads per log file. Then we have the log open parallelism that is helpful to choose the maximum number of during the parallel log recovery process. And we also have the log recovery parallelism that controls the number of logs files that you can recover concurrently. So having these 3 parameters at the time represents a very flexible mechanism that you adjust the way that you want to execute this parallelism in your environment and help you to improve the performance of your data recovery process. Another cases, including the utilization of newly introduced GPFS red replica rule, that is an extended attribute for GPFS. It helps you to determine which data blocks replicas are good to be used to recover a replica mismatch issue. So that is, you will have an easier way to select the reference data block replica among mismatched replica. This will help you to recover faster from replica mismatches and will allow you for a more granular control over which data block replicas are useful for a particular file. As future enhancements has been massive. I think this is one of my favorites. First, it is not possible to have, now it is possible to have a user-defined service classes. So using the QoS class create command, you can regulate IO access to files in file sets. So here in the slide, hopefully you can see it. You have some screenshots about how now you can see this class creation by file sets. Okay, so this will provide you very fine-grained control over how you regulate the IO access in your system. Okay, you can assign these IO limits to QoS classes, to the QoS classes in terms of IOPS, or also you can use it in terms of megabytes per second. You can display regular fine-grained statistics of the IO access by process over time. So as I mentioned, this is fantastic. I have been experimenting with this feature, and I believe it is awesome what it does. It provides you a very fine-grained control over the IOPS assigned. And the best of all, it is dynamic. That means that if a file set is not in use, its IOPS are split among other active classes based on their priority. No resources are wasted due to idling, and help you to improve the performance of your overall system. And second, QoS now is easier to use in Scale 510. Previously, we had the change QoS and ls QoS commands. Now, we have one single command, QoS command, that integrates the functionality of the previous two commands that I mentioned. So one single command, we can create, administrate, and track the QoS class.
One question related to that, Ismail, if you could go back. But the question is, if the file set operations Quota and QoS apply to both dependent and independent file systems, or file sets, sorry.
Yes, that's right, yes. Dependent and independent file sets can be configured with QoS. In terms of performance, Scale has been significantly improved for particular use cases. Okay, we have three very important for us. First, in previous releases for reclaiming storage space or trim, mechanisms have been introduced. Okay, these mechanisms work after the manual execution of the find commands. However, if the system administrator is not running periodically these mechanisms, the overall performance starts significantly decreasing due to the intrinsic characteristic of the trim-able media. Okay, so starting in 510, it is possible to set up a threshold for automatically reclaim space of such devices. That means that no more manual space reclaim and no more dramatic performance drops due to forgetting the execution of these trim commands. So using this automated space reclaim method, it is possible to reduce up to 60% the negative impact of forgetting to execute the manual space reclaim. This is not only helping you to maintain acceptable performance levels in your cluster, but also simplifies the system administration and the flexibility to decide when to run the space reclaim. So that means based on this threshold, you decide at what level of degradation you want to start just cleaning your devices. So it's very, very useful, so you can forget about manual commands and helping a lot the performance of your system. Other feature that is taking a lot of relevance due to its versatility is AFM, Active File Management. So in terms of performance in 501, Scale is introducing significant enhancement to the so-called fast creates. So that is very useful when we have workloads that generate a lot of files, for example, the untar and make. So, you know, when you're untarring, you are creating a lot of files from a single, and when you are making, you're extracting a lot of files from a single. So previously to 510, AFMQ all related create operations separately in a gateway node. That means we queue all the create operation. That means create the create operation and the subsequent operations such as truncate, multiple write, chmode, chon, set the extended attributes, and all these operations were queued in the gateway node. So this is, this was only for one file. So now translate this when happened with millions of files. So that means you were saturating the gateway node that you had in your environment. Now, for every create, we are just queuing the create operation. Okay, so in our gateway with a special flag that contains the necessary information to subsequently execute the remaining sub operations. That means the truncate, multi-block, chmode, and the others. So just one operation queue, and the remainings are not needed to be queued anymore. So this significantly reduces the RPC load at the gateway and helps to improve the performance around 40% when dealing with millions of files. And as previously mentioned, the user-defined QoS classes that allows the IOPS management at file set level. So as I mentioned, this is very dynamic. okay? And you can rebalance according to the utilization of each class. You assign as system administrator the importance of each class or the weight of each class. And that is a file set linked to a class is dynamically splits its IOPS among the others that are active in proportion to their importance or weight. So as higher the weight or importance of a class is, of course, more IOPS you will receive during this rebalance. This will help you to ensure the quality of service in active classes according to their importance that is given by you, by the system administrator, and reduce the waste produced by the idling resources. Previously to 510, this allocation was static, so IOPS remained allocated to a class even if this class was not in use.
Ismail, one comment that's been conveyed to me, this is Fred Stock, that the thin provisioning is not yet supported on ESS, just so people know.
Okay, great. Thank you, Fred.
Yep.
Now let me talk about the additions that we have in Spectrum Scale EC, Azure Code Edition. Okay, as we know, EC provides IBM Spectrum Scale RAID as software, allowing a customer to create IBM Spectrum Scale clusters that scale out storage on basically any hardware that meets the minimum hardware requirements. So all the benefits of scale and scale RAID by using your community hardware. That's it. The enhancements on ECE for Spectrum Scale 510 are mainly focused on extending the limits of the storage capacity per node that you currently have and to improve the procedures of problem solving. For example, the storage limit per node has been extended to 40 drives. I think previously was around 36. So the increment of 4 seems not to be that big. However, as we add new boxes to our cluster, we have a stronger impact in this enhancement. That means as we are adding boxes to our cluster, this enhancement that we're providing of 40 drives will have a stronger impact in your overall cluster capacity. Scale 510 is also introducing a new checkpoint for slot location. Now you will be warned before executing the creation of a recovery group if a PDISC is located in a wrong slot location. This will take out from your head a lot of problems. This for sure will help you to reduce the PDISC issues and also reduce the maintenance time frame. You have to look for these problems manually. Number 3, as I mentioned previously, the different problem solving procedures has been added and extended to provide you as a customer a better guide for maintenance and troubleshooting. For example, we have enhanced these procedures to better guide you through the steps for finding these that have problems. We have enhanced our procedures to add new recovery groups to help you in the process of adding more capacity to your cluster. And we also have enhanced the troubleshooting section in general to deal with particularly with issues related to suspended nodes and also with other disk problems. So in summary, for ECE, we have more capacity, reduced maintenance, and improved procedures for troubleshooting. For management GUI and API, Scale 510 is looking for an enhanced user experience by providing simpler administration and reducing the manual procedures. 510 supports turning on and off cluster watch, turning on and off a flag to indicate that a node cluster is in maintenance mode. We are also of IPv6 addresses. So enhancements of this type reduce the command line interface interaction, reduce also the problems that can be introduced by manual operation, and helps you to simplify your day-to-day system operation, concentrating basically at the moment not all, but more important administration procedures in place. Additionally to the GUI enhancements, several endpoints has been added to the management API. So including endpoints for COS, watch, and AFM. So as you can see, the variety of tools to efficiently administrate your system is growing and will continue doing it. To see the full list of endpoints, what I can suggest is just visit the Knowledge Center, the Spectrum Scale Knowledge Center, and you will have a complete list and description of all the endpoints that we have for the measurement API. Let's move to the enhancements for maps, monitoring, availability, and proactive services. So feedback always include more features to monitor the system health and proactive services. Spectrum Scale 5.1.0 comes with a very good number of new features and enhancements that provide you more detailed information on your system health. Some of these features include, first, getting notified when any of your access node is getting out of run. If you notice this in time, you can react in consequence and mitigate the stability issues produced by not having enough memory at the access node. Okay, so you are notified of this on time, and you can focus on resolve these problems to avoid these stability issues. Number two, you also are getting notified when a file system daemon is terminated abnormally. What is abnormally? Well, not following the normal shutdown procedure. So if you receive a warning in the moment that it happens, you will be able to focus your efforts on determining the causes and get operational in a fastest way. Okay, you don't have to be trying to figure out that it is the network or other related to your system operation. If you are notified about this type of issues, you can focus your efforts and you can get operational faster. Monitoring and system health in 5.1.0 is enhancing also the accuracy of the notifications for particular use cases. For example, sometimes MOMs created by AutoFS or bind MOMs are not at the default MOM point, as declared in the file system metadata. So this will trigger a false positive tip. So this will degrade the status of your cluster. Okay, now in Spectrum Scale 5.1.0, we are introducing mechanisms to verify that the MOM points are actually okay, and we are reducing the number of false positives. So this means more reliable alerting in the map services. There is also monitoring support for NFS protocols. Sometimes when you want to NFS services, you get timeouts. Okay, Scale 5.1.0 introduced two mechanisms to reduce this problem. First, we are adding some checks for the RPC stat process. Okay, and we are also adding a mechanism for auto restarting the RPC bind in case it becomes unresponsive. Okay, so this is automatically happening. Okay, it's checking the status of the RPC stat process and also checking the status of RPC bind. Okay, and automatically is telling you what is happening if they are I don't know, active, not active. And finally, if the RPC bind is not responsive, it restarts it automatically. This helps you to improve the availability of your NFS service with minimal manual intervention. I have to tell that all this is fully configurable, so you decide whether to automatically it or not. Okay, so that means if you want to continue manually checking the status of your NFS service, it's okay, and you can do it. If you want to configure this automation for restarting the RPC bind and checking the RPC stat process, you can fully do it.
Ismail, question came out going back to ECE. The question is if it can be used in AWS across EC2 instances with local storage. So could you take a set of EC2 instances with NVMe and run Erasure Code Edition across them to survive an EC2 instance failure?
So I was in the process of answering that, Christy. There are requirements for ECE that must be met. For example, we need physical access to the underlying storage device. In EC2, typically the instance store is provided through an vert.io kind of a mechanism. You're not getting actually PCIe pass through. So we cannot, our ECE pre-check will typically fail in those kinds of setups because we don't have the underlying hardware access. So we can't do things like background checks on if the device is healthy and trying to do some proactive error handling, et cetera, et cetera. There are also requirements about how much network performance is required by ECE. So if you run the ECE pre-check tool that includes both network and storage checking, it will provide you some kind of a baseline about will that work or not. Beyond that, there's a support statement. We are working with some cloud providers to test this out and try it out. There is no right now committed plan for that, but I suspect, especially for the AWS one, it's just going to fail the pre-check because neither the network nor the storage check will pass.
All right, thanks, PC.
Yep.
Okay, and continuing with the system health and monitoring, as I mentioned, it's a bunch of very good news in this particular area of spectrum scale. So we also have some improvements identifying which nodes are the managers in your file system. So now you can be aware that before executing any movement on those particular servers, maintain your system availability. For ESS 5000, Scale 510 introduced the monitoring of NV RAM devices. So this you will always be aware of the status of your underlying storage health. So there is also a new set of metrics for virtual file system that includes the mean and max latency for executed operation. In my humble opinion, I think this is a great addition. It is another tool that will help you to analyze the performance in your system. Could be to improve your system and could be also to help to solve any trouble that could occur for your system. So I think this is one of the most important, or for me, this is one of the most valuable additions in terms of monitoring. System health monitoring also includes some additions for QoS. First, now it's possible to monitor the state of the QoS and the state of the QoS performance monitoring. So you will see QoS state and performance state results listed under the Health category, File System Manager. Okay? And second, the integration of the monitoring system with QoS to provide historical performance data. This will allow you to analyze the performance of the binary classes and adjust accordingly to enhance the IOPS utilization. So do you remember these dynamic IOPS that I mentioned a few slides back? So, well, with this monitoring tool, we can efficiently analyze the data that we are obtaining from it and adjust the IOPS designation based on how these classes are actually being used, not just theoretical adjustment. Just you can have the data now with maps tools, and you can analyze this data and assign the IOPS properly. Now talking about Call Home, Scale 510 is focused on provide more insights with the data that we are collecting, and we are trying to make it simpler and more transparent for our clients. Now the installation is simpler. You don't need an additional package and the corresponding dependencies of those packages. At the time you install GPU space, Call Home is ready to be configured and used. Okay, that's simple. With the Spectrum Scale 510, you can get more detailed information on your cluster at a glance by a new cluster summary in EcoRep. This summary will help you to improve the understanding of your own system, as well as to identify points of inefficiencies and help us to solve the problems that you are facing. With the Spectrum Scale 510, the limit of home upload has also been increased. Previously was 2 gig. Now it's 8 gig. That means more data that can be analyzed to help you to improve the operation and solve your problems. Finally, now it's possible to enable or disable event-based upload in a cluster-wide level. So that means no more node-by-node configurations. So we are providing you now a simpler Call Home administration, so you can avoid this event-based upload at a cluster-wide level in a single command. I don't know if you have questions in relation to what we have discussed so far. If not, I think that's on my side. Thanks for your attention.
My name is Chris Maestas. Ismail, if we actually can go to the next slide. we'll sort of begin to talk about, other things in the presentation. But have no fear, we're watching your questions. We'll get them answered in this kind of environment. What we're going to sort of talk about here in the second half is, Ismail would give us the, great kind of presentation on the core, the installation, the kind of operating environment we can work with, as well as, health and monitoring, right? Very important for what's actually going on in Spectrum Scale. Really what we want to talk about here, again, protocols. We have the POSIX protocol, what core is actually doing in that environment. It's very important to make sure performance is always looked at, reliability, and the team is focused on that. From protocols, we've had NFS, and, we're not going to say that NFS has been, great from day one, right? A lot of folks, the CNFS and NFS Ganesha, right, sort of going back and forth in those environments, but it's getting better over time, right? Right now, the biggest, qualm we used to hear was, how about NFS 4.1? So yes, we're finally supporting NFS 4.1 in this particular release. Really better handling for drop connections, directory delegations, the parallel IO kind of nature. You can kind of see that, where we could go with this kind of support now in terms of other things NFS 4.1 could support. IPv6, again, is another thing that's sort of been, getting questioned about in the past couple of years. When is IPv6 going to sort of be there? So for NFS 4.1, it's actually there now, as well as, again, kind of consistency in other environments like the 390 environment, kind of supporting it there. Authentication mechanisms for these protocols, right? With LDAP-based kind of authentication schemes that using TLS or SSSD, trying to understand that. SSSD is a great engine to reduce the load on the identity and authentication servers, right? So that's essentially important, being able to do that within the realm of NFS authentication, stuff that we've learned in the SMB kind of world as well, right? Where it could actually cause some pain. If we actually go to the next slide, Ismail, and we'll basically be talking about, the other kind of, again, traditional file protocols of, SMB protocol access, right? So we're cadencing to Samba versions, right? We sort of not, been upfront. The NFS Ganesha and the Samba framework we use, Red Hat uses, a lot of other distributions kind of use it as well. So it's great. More eyes are kind of looking on this environment. And we're doing a cadence of improvements, again, in the SMB world as well. So again, cadencing to the next Samba version that's out there, and allow us to sort of incorporate that version and those enhancements as they come in. And of course, again, back to the S390 kind of environment, NFS being there, SMB kind of being there. I think that Amy and team sort of did a great kind of conversation. Like, we want to make everything the same, within the Power Z x86 kind of world, right? And we're getting there now in what's going on. Object protocol, it's something that I've been working on, kind of updates. Actually, I think one of the panelists, Ted, is on, and we've been working through lots of stuff within these kinds of components. So things are going very well here. So there will be an upcoming PTF that will sort of sync in the object protocol to 5.1. So stay tuned for that. But just kind of want to let folks know about that with regards to these kind of protocols. We could get to some of the newer protocols in Spectrum Scale. We go to the next slide, Ismail, and we can sort of talk to essentially containers. Last year around this time, we had the container storage interface beta. At Supercomputing, we were talking about it, and in December, with 1.0 released, it was put out, there for everyone to be able to look at and observe. We've been doing a really good cadence. I think we even have a 2.1. I say 2.x because it actually just came out, I think, a couple of days ago for the next GSI release. And, it's supporting OpenShift and Kubernetes environments. There's the versions of Kubernetes 1.18. And then again, OpenShift environments that are, 4.4, 4.5, since 4.3 essentially. 4.6 will get supported. We're working with Red Hat in that environment. I know that they just released 4.6. So we're kind of trying to make sure that things are going to work within our CSI driver as well. So, stay tuned on that for sort of doing that. 4.7 what you can do with this release now is, the way we're debugging data, collecting data. If you've ever configured CSI, you had to do a cluster ID parameter. So you were trying to do an MMLS cluster, go find this, number on there and actually pass that in. Not, really necessary or mandatory anymore. It's now optional, not really necessary. So you can sort of have CSI be configured a lot easier. And then again, moving again to supporting for when if I have a secret already in a that I can just pull from, right, that has the secrets, I can just pull that rather than sort of having to set up my own. We can go to the next slide and sort of see what we're doing with the container, storage interface. It's been on Operator Hub since our first GA last December. It's been on GitHub as well, right? It's actually part of our beta program. We put it out on GitHub. People can contribute, can file, cases or, kind of information on that to post it. You can actually, use it within the plugin operator of OpenShift, right? And that we've actually written Redbooks against and sort of showing how that actually, have that whole ease of use. So making it easy to use, open source to give feedback for any kind of improvement. That's our cadence here with what we're doing with the container storage interface. And if we go to the next slide, we can sort of see, this CSI framework has really helped us to do something, very interesting within Spectrum Scale. We had a talk on this a couple of weeks ago about, containers and Spectrum Scale and what we do, right? I mean, I think that the team has been they're doing a great job with the cadence on these talks. But really what we see coming soon, and it's when I say soon, right, I don't mean years, right, or quarters, right? So you can sort of think, about that. Essentially having Spectrum Scale cross-cluster mount a storage environment. So that could be an ESS. It could be an instance running, you built it yourself on some VMs or, in maybe in a cloud, right? You're sort of looking at that as well. But what we're doing on the left-hand side is this journey that the development team has sort of taken us through in looking at, something like Red Hat CoreOS, right? With containers, we were able to deploy it on worker nodes that were Red Hat-based, Ubuntu-based, not a big deal. When, you have kind of an operating environment that's read-only and you can't just, willy-nilly install stuff that you want, you have to make sure that, you work with Red Hat to get what you need there and qualified. So the team has done a great job there to have Spectrum Scale be in a compute cluster now, managed again through this OpenShift environment, and stand up services, containerized kind of services that you sort of see where health and monitoring is there. The GUI in 5.1 is is containerized in this kind of environment. The core functionality and really putting up a Spectrum Scale compute cluster that can mount external storage, have that be automated, right? And sort of doing that, that's really, impressive, right? To sort of automate Spectrum Scale, not having to sort of think about what happens when, something goes wrong. How do you recover from that in the environment? And most importantly, was this Spectrum Scale, GPFS, right? With speed, performance, right? So kind of giving you the performance to that storage that's almost as if you were running on bare metal, right? Essentially, anytime you do something within the community of what we're doing in Spectrum Scale is the performance impact is always top of mind. And you want to make sure that, whatever you're doing now with containers, that you're getting near better metal or bare metal like, performance in the environment. So this is new. This has been, spoken about as well in the environment. So that to be there, to Bernard's kind of question about this is only for CoreOS initially that we sort of have been looking at, should be made available for Kubernetes environments. Yes, we're working on that. We wanted to get the OpenShift kind of environment done first and sort of make sure that kind of proves out, right? Let's get the steps that we have here at IBM first. So that's kind of done initially for this Spectrum Scale container native storage access, right? Again, coming very, very soon. And the other, component we have is a protocol. And if we just give me another click, Ismail, we'll sort of see that, what we've had, I think, like I said, since Big Insights days of IBM, right, when we did our own cloud, Hadoop distribution, Spectrum Scale, FPO, sort of came out and tried to do, an HDFS kind of integration layer, right? So we've had this kind of, again, top of mind to have the Spectrum Scale instance, have a POSIX interface, have HDFS interfaces, right? Really extend what you're doing in computing when it comes to, Hadoop, open source, Spark environments. And with this big news of Cloudera and Hortonworks merging last year, right? How are, we going to sort of work towards that? So we've been working with Cloudera, and their Cloudera, private cloud base, essentially is what they're sort of doing, and making sure Spectrum Scale works in that environment. So that's, the enhancements there is making sure we're cadencing to newer releases of commercial Hadoop releases that are out there. And if we sort of go to the next slide, we can see the, kind of configuration. So the transparency layer that's been around and evolving, right? The team, that PC has sort of worked with as well over the years has been fantastic. I mean, these improvements every now and then, you stand back and sort of see Cloudera Manager integrating within, the transparency layer as well. So you can, make things easier for deployment, with the impacts that we sort of have. Whenever you're using encryption, like with Ranger, be a little bit mindful about the way you're doing fine-grained system locking and some of these improvements. So this transparency layer, includes Hadoop scripts to create users and groups in your Spectrum Scale, and your Kerberized, principles and key tabs in your environment. Again, continuing to enhance, working with open source Hadoop, working with Cloudera private cloud base, as that's getting formalized into the official kind of release here in their kind of end as well. We can sort of see that, the container story, the NFS story, the SMB story, right? Traditional stuff and new stuff. This is exciting as it may be in Spectrum Scale 5.1, right? It doesn't stop there, right? So we had a user group meeting, I think it was in Boulder, Colorado last year in the March kind of timeframe. And in there we had discussions about how do we want to do file system level migration? Because there was a lot of commentary about this version 4 to version 5 file system format, right? So we had a good discussion that was led there, and we sort of think, well, input, insights, how do I do file system level migration using various technologies? And at that particular meeting, again, we looked at bringing AFM as the framework for doing a transparent migration from legacy appliances or, the older kind of formats to, version 5 kind of systems. Granted, this is a framework that's been developed over time. It's something that may have not been ready when you were doing it. I know that, talking to other folks, even on the mailing list, right, we're still talking now about how to do changes and move things with, rsync or other kind of commercial tools that are out there that I've been involved with other clients. But right now we have, an initial framework for support of file system level migration with AFM from one kind of environment to another. Because we've kind of done that, we want to make sure that the gateways, right, as they're moving data back and forth, are trying to be as fast as possible, right? So there's a new parameter now to essentially change that and making sure that we're load balancing amongst all of the gateway nodes when you're doing the migration in this kind of environment. So that's kind of a good big first step for AFM and file system migration, based on, conversations we'd have had within the user group community. The other thing we've worked on is disaster recovery for AFM. Used to be that you had to fill out a questionnaire and, answer a lot of questions before we would, development would approve you're actually going to be okay to use DR. And one of the things we actually did was put those guidelines, right, in Knowledge Center or in kind of environments where we have that checklist available for you. It's not sort of internal kind of things we're looking at to sort of spot check you, but we're going to make that is made available now, and you can sort of see the guidelines what, how to get the best of this, setting up AFMDR. And again, that's another good first step in this, again, whole realm of this second half talk of protocols and AFM. That stuff we did with Samba in the last release, right? In SMB, we're doing it for AFM now. So again, putting these checklists that are out there, make it easier to see the guidelines that you need for AFMDR and not, just see where the boundary is, right? See how that documented and improve upon this checklist, right, that we're doing on it. It's out there, now we can improve upon it. Finally, for Spectrum Scale, kind of having AFM operate in a kernel that's booted into FIPS mode. So making sure that AFM could be supported within that kernel, just kind of spot checking that at the end of the day and making sure that things are great there. But on the next slide, the big thing that you kind of have heard for us, and as Ismail transitions here, is that you'll sort of see this concept we talked about, HPT, high performance tier. What is it? And we were, had the picture of the elephant. What part are you touching? What is it really? We've had these concepts of data acceleration for AI and analytics. And again, we talked about this on our Monday call in the Spectrum Scale kind of user group here this week. What we've done is really allow AFM to connect to cloud kind of storage, right? So you can have data placed in a high performance tier, like running an ESS 3000, for example. It could have the ability to connect to remote object storage that's living on Amazon, that's living on cloud object storage on premise or an IBM cloud, and push and pull data from what we know of AFM relationships today of single writer mode, read-only mode, independent writer mode, local update mode. So have all of what we know and what's easy about AFM today to set up be now available to us to connect to an object store via S3. So you're now sort of seeing that your objects, environments can be used to push data for storage when I'm done with it, and sort of connecting to various environments as part of the beta program, that we actually had, and that I participated internally, but some of you externally as well. I worked with a couple of clients that were testing this on, more than S3 and cloud object storage. That's what we have on the truck today, quote unquote. But we are testing other S3 endpoints. I think I've chimed in. Doing other testing is pretty fun. To sort of see if it actually works with something like I think with MinIO or Ceph or NetApp Storage Grid. These other kinds of S3 endpoints, right? So we're still kind of looking at that. What we sort of see is today, right? We feel comfortable with Amazon S3, Cloud Object Storage, and IBM Cloud is fine, and on-prem is fine. If you sort of say, could this other object storage be supported? We'll work with you, right? And chances are we're already testing that kind of connectivity internally. So we kind of can reach out to us. So I know some of you have been asking, like Kurt and Paul, we can sort of help you, work through these kinds of testing that you're doing with that, help us in our testing and expedite, what we're doing for AFM to object storage. How do you set it up? Well, in your object storage environment, you're going to have a bucket, you're going to have the access key, you're going to have the security key. So, that's just, what you typically do on an environment. Although, if someone ever wants to inform me on the Amazon console how easy that is to get, I'd love to do that. I gotta figure that out again. It's just gotta clear out the cobwebs. A cache cluster, which is your Spectrum Scale environment, you essentially are going to set up the gateway nodes, right? So you're going to set up the dash gateway on the nodes that you're sort of going to set up in that environment, and provide that. The file sets, essentially, you're going to take that bucket name, the access key, the security key, and we're going to need that information for the various buckets you're going to set up in relationships. And then you have a command, MMAFM cause keys is going to sort of get the credentials. MMAFM cause config is going to talk to your file system name. It's going to create the file set on what you want it sort of to be, and you're going to give it an endpoint, right? And that endpoint is going to be an HTTP or an HTTPS URL. You may have some flags, like in this one is add extended attributes to the environment, and you're going to give it the bucket name that you're doing. So literally in 2 commands, for how you actually sort of set this up, you can connect to an object store on the other end and have Spectrum Scale see it. It's really, like I said, quite easy, quite amazingly easy sort of doing that. And I've sort of been impressed to do that. If you sort of see on the next slide, and this is, I promise, the only build out slide in the deck, but essentially, we sort of click maybe about 3 or 4 times, Ismail. You'll sort of see what we're trying to sort of give you the ability is Spectrum Scale kind of can talk to AWS today. We refreshed that offering of AWS, and that's Spectrum Scale 505. We have Spectrum Scale able to run on IBM Cloud as bare metal kind of instances, looking at other ways of running it there as well. We had Oracle talk last year at Supercomputing about their experience doing Spectrum Scale on their cloud, and we had a partner, figure that out for Azure this year. With this kind of capability in AFM, and I've actually been able to demonstrate this today, my on-prem environment that's running Spectrum Scale can push data to my IBM Cloud bucket, and IBM Cloud Object Storage, and then that Spectrum Scale instance running in IBM Cloud can connect to that same bucket and access the data, right? Is it, in milliseconds or microseconds? No. This is active file management, which is an asynchronous replication. That means, it takes some time, right? It's not going to be something, there's tunables you can sort of work with in all that environment, but, it's really basically able to connect to the 2 environments, share the data amongst that seamlessly in doing that. And, right now in AWS, we have Spectrum Scale 505 that just got deployed. That'll cadence to a 5.1 release. And essentially you have that same kind of capability. Today in AWS, we actually have demonstrated Kerberized NFS to talk back and forth between the instances. But again, what AFM with S3 here now allows us to do is to centralize your data and have multiple, Spectrum Scale instances connect to that data with AFM, still access that data via S3 and push and pull, right? So this is a big kind of change in how we want to bring data into Spectrum Scale and how we can push the data back out. In security, right? I mean, this is another thing, we sort of are working towards every time. And I meet with clients talking about, well, how long does the key cache, sort of live on the environment, right? So there's now an attribute to specify the refresh interval of that. We really had that internalized, and we didn't have that kind of out there. So that's there now, as well as dealing with, signed certificates to make sure you can import them in a one-step kind of process, as well as NIST compliance, right? You're actually trying to be NIST and FIPS compliance. You want to set that attribute so sort of your clusters know that, so your security is strong and running at that layer in this environment. The other thing is sudo wrappers, trying to be more conscious about all the commands you were having to add in the sudo files. So try to think about, do I really need to have this as a sudo command, or the Spectrum Scale command able to do that, from the get-go, right? Why do you have to have a separate command to do that? So it's kind of simplifying this kind of thing in the security aspect of Spectrum Scale. And then finally, in the other aspect of security on the next slide, if we sort of go to, we'll talk to audit logging. So, one of the things, we added to audit logging was access denied events, right? So who is accessing stuff that they shouldn't, right? And being able to sort of have that environment there. Right now, it's for POSIX only, right? So this is just kind of, native access. So when you're using Scale clients, when people are logged into that system, trying to access stuff that's being audited, you'll sort of see those events, kind of working out the details and in protocols and other kinds of environments. That's next steps. So, we have our work planned in that environment already to enable access denied events to work there. But again, it's big to sort of see who's accessing what and what they shouldn't access. And then audit logging, file audit logging, used to require its own, message queue, its own Kafka kind of RPMs. This, for, some of the panelists, I know, I think I saw John and Fred and DePaoli, like I said, we worked on some interesting client challenges this year where, that this was being used and this was being used in a stretch cluster. And, we really, kind of had to take a step back and, and sort of think about what we were doing here. With 5.1, the message queuing not being needed in file audit logging simplifies things a lot. To administer file audit logging, set it up, have it run within the cluster. As things change around the cluster, you're going to sort of be all right in this environment. So this is a great simplification change to have this file audit logging environment run faster. What does this mean? We had started down the path. Sandeep and Kedar have sort of done these kind of other, security kind of bullets with QRadar and Splunk, and sort of seeing what we could do from a red paper kind of standpoint of integrating file audit logging. So this simplification now, again, makes things just, again, a little bit easier on the setup time. We do have a integration with QRadar and a red paper that's out there. There's actually a video on YouTube you can check out that gives you step-by-step kind of things. You can see that file audit logging events are being generated. QRadar can sort of act upon that data and do that. And we also have a video for Splunk. We're figuring out if we can get that, published on YouTube as well, but kind of integrating, what we're doing in file audit logging with these other, other security tools and kind of giving you the security aspect of Spectrum Scale to that. At the end, I think of every talk, we sort of talk about, well, what's changed, what's not going to be here anymore. And this is kind of, coming to that kind of end. So TLS, right, please be, consider running to 1.2 or later, right, 1.3 for that particular support. So again, don't run 1.0 and 1.1, right? It's really for the REST API, and from a security aspect, really we're recommending that TLS 1.2 is the environment. We're discontinuing these other older protocols for security and asking you to go to the new versions. From a platform perspective, looking at, some of the acceleration libraries we had for Power 7, we're sort of thinking Power 8, Power 9 may not be as critical anymore for actually having this. So you can, still have encryption there, as well as Big Indian Power servers, thinking about, where we're at with now Power 9, Little Indian, and that environment. From a protocols perspective, I think, we've tried this over time. Should be no surprise that iSCSI is not, there anymore. So use block services differently with, Spectrum Scale is not doing that with anymore. And then from containers, storage enablers for containers was something we used to have. Now that CSI has matured over the last year, that's the action that we want everyone to sort of consider and moving forward towards. If we go to the next slide, we sort of have some other, categories around security. We deprecated VOR metrics. So SKLM is a secure key lifecycle management from IBM. We worked with VOR metric as another key manager, and now we're saying version 5 is not worth it. Well, it's not. We're not doing support for that. Sorry, it's not worth it. We're just not doing support for it. Go to version 6.2, and it's actually interesting because I was talking to a recent client about this, and they were using this particular key management system, and it was at 6.2 where we kind of figured out everything is now safe to move towards, the way that VORmetric was doing things in 6.0 and 6.1 wasn't there, but this is the action. 6.2 is for you want to do if you want to use VORmetric. Watch folders, we just talked about that. There's no need for a Kafka queue anymore. In watch folders, essentially having Kafka for an external Kafka sync is something we've talked about previously, where watch folders could dump to a Kafka sync that Spectrum Discover is reading, for example. So that's kind of how that's been implemented, even in past talks. Again, in platforms and protocols, Power 7, please think that migrate to newer power systems, and then as well as for protocols for DR, right? Again, looking more about the checklist, what we're doing with AFMDR to set up the strategies in what's actually going on within the clusters. I think this is probably going to, next slide, kind of bring us to the end of our talk. If we sort of go one more slide, as always, please log your RFE. Carl reads these. Carl helps to use this to guide and present this, and development team is looking at this as well. IBMers, we don't really submit these because Carl doesn't listen to us when it comes to an RFP. Essentially, you're the client, the partner. We feed that. This is where you can have a voice in what's going on in Spectrum Scale. So try to get that done. Certainly, voting, for that as well. I know the user group has talked about that in the past and how we could do that in this environment. So if you have an RFE, it doesn't have to be public. You can make it private as well. But again, we're going to read that and help prioritize various things within development and Spectrum Scale. And then finally, I think on the last slide, if we go to one more, we should have the, check out for past talks as well. I think as we're looking to close here, I wanted to maybe hand it back to Christy and team to sort of see if there's other, and Simon, if there's other questions we might have missed.
Thanks so much, Chris and Ismail, for a great talk. Lots of new features, and glad you're still keeping in mind the data migration issue that's been discussed, many times. So I give an opportunity now maybe for some of the folks in the background helping us out with Q&A to jump in on some of the questions you haven't been able to type answers to.
One answer actually to a question about BE that I'm slow on typing out. So on ESS, the BE will continue to be supported on the 505 stream. So it's not impacted by the deprecation of BE.
All right, well, thanks again, everyone, for your participation today. Thanks, IBM, for the speakers and following up on all the questions. And if you have something that didn't get answered, remember we have the Slack channel that you can go there as well.